Welcome. See, today's is question 36. I will call it as ultimate master question covering all types of triangles. All triangles in one class. See, this is a given. Question. Find moment of inertia about centroidal axis, both. Axis means what? Plural. X, X, Y, Y, both you have to calculate. Okay. All dimensions are in millimeter. I written here. All millimeter. Space problem is there. When I put the sketch, if slight turning all is there, don't bother. I cannot stand here and correctly take a set square and spirit level and maintain it. Now, class. Advice come warning. Advice green color, warning red color. After today's class, when triangle will come, whether right angle triangle or isosceles triangle or triangle in general, whatever comes, I will not keep on telling same thing again and again because today's class our covering. So advice to you is thoroughly work out. This is test for your patience and also a test for your what you can call is hungriness for knowledge, your eagerness or your tendency to learn. See, I already told, when I conduct a class, I go for perfection, no doubts. So people who will go through my class, if they understand everything and follow whatever I tell, I assure that they will reach the ultimate level. Sometimes people will tell, why you want to have this one? See, by all this example only, your level of knowledge will be higher and higher. Okay. Warning. For those who are not serious, ignore this question. Later, doubt comes. He is not telling why he wrote there BH cube by HB cube by 48 suddenly from where it came. And sometimes he is not telling 1/3, 2/3 all. Sorry. I will tell it is your problem of not being serious. Okay, sufficient. This every class I am telling it. Okay, now this is a question. See, 600 is this dimension. See, dotted line is there. 600, 540. This height 300. This height I have not given here. I will give it. It is 315. Given in the question. Forgot to give. Okay. This is 315. 315. See, 600, 500, 540 is a rectangle. Then height of 300, triangle will start here. 240 is this one. Other you have to calculate. Join here. Then here. Total 540. Come by 225 and see 225 and 315. Join. Right angle triangle. Base already known there. 180. This one. This is 540 means total 540. 270 here. And this height is 225. Okay, now first write the sketch. Then there is no place to write here. You show first you copy this question. Okay, then write the sketch once again. Write the sketch once again. See here. Let dimensions be there only. This all remove it here now. Now what we will do is, see now, we will divide into a rectangle. See here. A rectangle. First one rectangle. One more sketch you have to write. This is a rectangle. I will put dot. Later dot is not there. Dot, rectangle. Okay. I will call it as part number 1. Then, see, this is, yes, 240 here. Total is 600. If this is 240, this is 600 minus 240 is 360. See there? I wrote here 240 here, 360 here. I will not once again explain here. See, you put dot here. Already over, explained. 600 explained. Okay. Now, this is a triangle in general. I took one exclusive class. Here, if you want I about XX, there is no problem. But when you want I about YY, complication, see, if you remember, complication. So, we do not want complication. So, If complications are there, what we will do is, we will divide like this. This is one triangle, this is other triangle, so that no confusion. See, two triangles we will divide. So this I will take 2, this I will take 3. Then same thing here also. See, the base is 540 in this triangle. This is 255. This is 540. This is 255 means this will become 285. See, I written here 255, 285. Already explained. Once again, I will not explain once again. Now, once again, same problem. It is triangle in general. So to avoid confusion, we'll divide like this and take one triangle separately here and this one separately here. See, separately here. There I won't hatch actually. Okay, over. This is 1, this is 2, 3. I'll take 4 and 5. Now, come here. Very happy case. Right angle triangle. Okay, 6. Single triangle. See, right angle triangle is single triangle. Now, lastly, come to this triangle. 540 is the base here. See, and 270 here. If this is, see here, given 270, if that is 270, it is actually midpoint of 540. See, if it is 270, this also 270. Oh, this is isosceles triangle. Dividing into two parts is not required. Waste of time. I see right angle triangle or isosceles triangle. Moment of inertia should be isosceles triangle. One moment of inertia is BH cube by 36 as usual, but other is HB cube by 48. I told you. Therefore, this triangle we will maintain single triangle. See here, right here, single triangle. You will take single triangle. The triangle number I will take 7. See, common for both, 7. Okay, single triangle. See, that's why I wrote here. Okay, now start. Dimensions. 240, 360 explained, 600 explained. Then 315 given. From here to here is 315 given. From here to here is 225 given. So 225 plus 240 plus 360 plus 315 or 225 plus 600 plus 315 will come total from this extreme end to this extreme end. Outright is, see, full outright is 1140. I'll check once again, safer side. Correct answer. I don't want any mistake. 225 plus 600 plus 315 equal. Yes, 1140 full over. Vertically, see, this height is 300 given here. 300. 270 and 270. And 180 is this one. 300 plus 270 plus 270 plus 180 or 300 plus 540 plus 180. Whatever you want. 300 plus 540 plus 180 is 1020. The total, the rounded number is the total depth. Full above outermost here, see. The total is what? See here. It is not from there, sorry. The change is there. See, to understand correctly, slightly it has gone there. See, from this level. Oh, sorry. Slight shifting there. Okay, no problem. That's all you can make out. That is a dimension line. See. Okay, now correct. This one. From this level, see, from this level to this level. 1020. Now, here, this triangle property is 540, height 225, it is there, 225, both are 270, 270. But here, see, 255 is this one, see, be careful, 255 is, if I project here, see, it is less than 270, you should be careful. And 285 is more than 270, here also, see, this is 240, 240. I somewhat maintained scale. Okay, then everything clear. Now do one thing. Everything is clear. I will remove that one. Now see, figure 1 rectangle. Now I am not going to hatch here. Why? If I hatch, figure is cancelled. It looks ugly. So 1, 2, 3, 4, 5, 6. This full is 7. Make a note here. 7 is not 2 right angle triangle. Make a note somewhere. Your 7 is, the 7 is where? You write here. The 7 is single triangle, that is isosceles triangle. You write there, full. See, I hatched here. Okay. Now everything is over. Now, lot of work is there. This question is the ultimate master question. Once this question is over, I told, advice, warning, everything. This I will remove now. Master, everything correct? Yes, okay, everything correct. Okay. This I will remove. One space. Now, write the usual statement, what all I dictate. See, you make this a perfect. Once this question is clear, in future, your worry is only circle, semicircle and quadrant. Circle is not a problem, or circle is very simple. So in future, your only concern will be semicircle and quadrant. I will thoroughly explain same way. I will again do a master question there, where at least 2 semicircle and 2 quadrants will come. Okay. One more second master question. Now, write. What all I dictate. You should write it. See, those who are serious, they should write everything. Required to find moment of inertia about centroidal axis, that is I about xx and I about yy. Xx and yy are horizontal and vertical centroidal axis, that is horizontal axis passing to centroid capital G, and also vertical axis passing to centroid G for the entire given sketch or area. So first you have to locate G. You require x bar and y bar. X bar this way, I will take from OY line. See, space is not there. See, OY. X bar, x this way, and y this way. See, x is from OY, y is from OX. Then write x bar from O, you write here, then x bar from, I won't waste time here now. We know that x bar from x bar, which side? To right side. See, x bar to right side. This all you are right, to right side. From OY equal to right here. A1 x1, A2 x2, A3 x3, A4 x4, A5 x5, A6 x6, A7 x7 divided by total area A1 plus A2 plus A3 plus A4 plus A5 plus A6 plus A7. Same way, right? Y bar, see, in the upward, vertically up from OX axis is A1, Y1, A2, Y2, etc. There is no cutout area, all positive. If something is removed, it will come later. Up to A7, Y7 divided by total area, write that formula. Once you write everything, now if you do not write properly and skip what all I told and later tell something is not clear, you pay penalty by how? By not getting the correct concept. Okay, now I'll do one thing here. See. Part number, I'll check the board. Part number, area A, small a, it is in millimeter square. After area A, okay, this much space, sufficient. X to right side from where? From OY. Once that is over, Y upward, see, X is right side, Y is upward from OX, that is upwards. Okay. You fill up this one correctly. Part 1, etc. Up to 7 you are required. Time counts, I will write and explain. Now we will start calculating x bar, y bar. Remember, before that, first you mark centroid of all the components. See here. See, this is the last time I will explain for rectangle and triangle. We got, see, a triangle in general. Because of the complications, we are dividing into two right angle triangles. Here also, a triangle in general, again we divided. Here we got a beautiful right angle triangle. Here we got isosceles triangle. So isosceles triangle, don't divide. This all I told. So next class onwards, when rectangle and triangle comes, don't expect me to tell this much. Okay, start. Rect 1, 2, 3 number I told. Centroid here, see. This is 600. 600 by 2, 600 by 2. Okay, centroid G1 over, midpoint. G2, see, correct, clear. 1, 2, 3, 1, 2, 3 part. Centroid from here you have to start, see. Centroid is near to the point where right angle is there, see. 1 by 3 of 300 or 2 by 3 of 300. 1 by 3 of 240, 2 by 3 of 240. Told maybe 1000, more than 1000 times told. G3, see here, divide into 3 parts here. Now see, from here, 1/3 of 360, 2/3 of 360, 1/3 of 300, 2/3 of 300. Okay, here, see, here, G. 1 by 3 of 315, 2 by 3 of 315, 1 by 3 of 255, 2 by 3 of 255. This centroid, G5. 1 by 3 of 285, 2 by 3 of 285, and this way. 1 by 3 of 315, 2 by 3 of 315. This triangle I marked here, centroid is here. G6, I wrote it, rubbed it, okay, G6. See here. Divide into 3 parts. Little this side, okay. 1 by 3 of 600, 2 by 3 of 600. 1 by 3 of 180, 2 by 3 of 180. G7, last time I will tell, this is isosceles triangle. We take a single triangle. Therefore, see, this is the base, this is the height. So with respect to this base, height wise, 1 by 3 of 225, 2 by 3 of 225. This way, along the height. And along the base, it is isosceles triangle, exactly center. No 1 by 3, 2 by 3, exactly center. If it is 540, 540 by 2, 540 by 2, or your G7 and G1 vertically will coincide. Same way here, see, G2 and G3 horizontally will be same level. G4 and G5, see, vertically, see, same line here. This is same distance, but see, this is same, but this way is different here. This is same, okay. That way, right. Now, part number 1, 2, 3, 4, 5, 6, 7, area 1, 600 by 540, I wrote there, okay. 2, half into 240 into 300, 3, half into 360 into 300, 4, half into 255 into 315, or half into 315 into 255, whatever we want. Half into base into height for this one. Half into base into height for this one. This full triangle, half into base, base is full base, 540 into 225. I wrote all the area, add all the areas, you get total area. Okay, now you require x bar, y bar, right here, this is called Abelco, see. Abelco. I won't tell what is Abelco. Go back and see. Extreme bottom and extreme left corner origin. I told earlier, somebody may tell, that is Eterco later. Abelco Eterco is my short form. People who are sincere and really want to learn, they know it. Okay, see, now, see, this side, extreme left, extreme bottom, this point, see. This is your origin O, x this way, y this way. Now, one by one, x you try. Start. Figure number 1, part number 1. From here, x, see, this means, see, actually from this line, x, see here, 225 plus half of 600. I wrote here. 2, there is 2 here, see, from here, x is this way. 225 plus 2 by 3 of 240. Okay. 3. 225 plus 240 plus 1 by 3 of 360. Here. 4th one. 225 plus 600 plus 1/3 of 315. Or I wrote other way, or 1140, see, 1140 minus 2/3 of 315. Both will give same answer. 5th also same, why waste time? How much is x4? Same for x5, y, same distance for x5. x6, 225 plus 1 by 3 of 600. 7th one, from here, 2 by 3 of 225. Okay, over. A1 x1, A2 x2, A3 x3, A4 x4, A5 x5, A6 x6, A7 x7, divide by total area, you will get x bar 532.273 millimeter. Okay. I won't waste time now. How much? That is to right side of origin. 1000 time told. Okay, then y, figure 1. From here, see, 180 plus half of, total is 540. See there, 540 is there. 180 plus half of 540. Figure number 2. 180 plus 540 plus 1 by 3 of 300. But I wrote other way, or 1020 from here to here minus 2/3 of 300. That is better. Okay. Same for figure number 3. Figure number 4, see, or part number 4. 180 plus 285 plus 1 by 3 of 255. Where is it? Yes, here, 1 by 3 here. Figure number 5. 180 plus 2 by 3 of 285. Figure 6. Oh, very easy. From here to here. 2 by 3 of 180. Okay. Last one. Here. See, this way is 1 by 3, 2 by 3. But this way is center. 180 plus, don't see here. 180 plus 540 divided by 2, or 180 plus 270, you get y bar. A1 y1, A2 y2, A3 y3, that all you write correctly and get y bar 475.913 millimeter up. I took great precaution while calculating. You can observe something. All distances are round number. Why? Because I do not want here 0.716667. I want to avoid that one. So what I did is, all the numbers maximum, I took multiple of 3. If I take multiple of 3, when you take 1 by 3, 2 by 3, decimal will not come. That I took, so otherwise space problem will come here. Later, see, everywhere you have to write what? See, 448, 418.96, 4444, etc. or 33333. To avoid that one, I made it easier. So, but see, this these 7 parts will never come. If when you get 2 or 3 parts, decimal, let it come. You write third decimal, you are knowing it. Only for this question, I took precaution of avoiding the decimals. But x bar y bar decimal, I am helpless. X bar y bar decimal, I am helpless. Okay, this is over. Now, just a minute. Continue. For your information, it is actually nearing midnight now. At record night time, because where I stay here, lot of sound disturbance comes in the daytime and evening time, vehicles. And my mic is an ordinary mic. I don't have that sound absorbing, what you call sound removing mic. I don't have. Simple mic I am using. And I have not taken the dinner. So, nearing midnight. Therefore, I went and finished and came back now. This will show how much effort I am going to put. I can tell something and leave the question. No, this question, who will ask me to solve this question first of all? But my purpose is you get perfection. See, now to get perfection, do one thing. X bar, Y bar over now. See, 532.273. The actual number is 532.2727273. Y bar, 475.913. Actual number is 475.912756666. I am rounding up to third decimal. Now do one thing. I will tell you why I wrote it. Now, those who are serious, last chance for you. Do one thing. Remove this OXOY. Remove this OXOY. Do one thing. Go here. Those who are see, go to Aterco. Extreme top, extreme right corner as origin. Okay, see. Extreme top here. Extreme right here. See. Take origin here. Take this X and take this way Y. This all I did it in the centroid class. Now not required, but perfection. See, start once again. I wrote the numbers here. See, A1, A2, A3, A4, A5, A6 remains same. You write one more table. See, this is your X1, X2, X3, X4, X5, X6, X7, Y1, Y2, Y3, Y4, Y6, Y7, Y8. Green color one. See, Y1, Y2, Y3, Y4, Y5, Y6, Y7. Start. Figure number 1. X1 from here. 315 plus half of 600. 615 will come. Okay, then figure number 2 or part number 2. 315 plus 360 plus 1 by 3 of 240. 755 will come. Figure 3. 315 plus 2/3 of 360. 555. Figure 4. Here is it here. 2/3 of 315. 210. Correct 210? Correct actually, should be correct because I got same X bar value. 210, correct, it should be correct. Okay, next. Figure number 5. Once again, 2 by 3 of 315. 210. Figure 6. From here, see, 315 plus 2 by 3 of 600. 715. Figure number 7. Full 1140 minus 2 by 3 of 225 or 315 plus 600 plus 1 by 3 of 225. 990 will come. A1, X1, A2, X2, A3, etc. X bar will come 607.7272727. You add these two, exactly you will get 1140. See how this is called perfection. You will get 1140. Next, Y. Figure number 1. From here, from top level. See, I can refer here now, top, this way Y. 300 plus half of 540. 570. I won't show it here. See, Y1, Y2, Y3, 570, 200, 200, 470, 650, 900, 570. Okay, it is not visible for you. 2. 2/3 of 300. 3. 2/3 of 300. 4. 300 plus 2/3 of 255. 5. 300 plus 255 plus 1/3 of 285. Figure number 5 is 650. Okay. 6. 300 plus 540 plus 1/3 of 180, or 1020 minus, see, 2, you measure here, 2/3 of 180. 900. Last one. 300 plus half of 540, that is 270. 570. Calculate y bar, it will come 475.91, 544.0872 will come. Okay, now everything I will remove. I will mark x and y axis and moment. See, actually, for your information, up to now what I have done is already over in centroid, first of all. At that time I used to tell, see, when I go to moment of inertia, I will not talk a single word about centroid. I told there. But my student will tell, sir, will tell that way. He will again tell, his nature is that way. They know my nature is that way, means not a bad nature. That is, as much as possible, give information. See, everybody is not like me. For me, no confusion. People are there who get confused. So, revision. I require more and more effort. Yes, I am putting it for your benefit. Okay, now, this full I will remove. Actually, our real class will start from this step. Okay, now correctly mark centroid. Be very careful now. See, if you randomly mark, you'll have a problem. See, from this OY axis, x bar, we got 532.273. Now, see, where is it? I told x bar is 532.273. See, I rubbed it out. I know the answer. Okay, start. 225. Furthermore, 225 plus 240. 225 plus 240. 465. Furthermore, 225 plus half of 600. 600 by 2. 525. Furthermore, up to here, 225 plus 240 plus 1/3 of 360. 225 plus 240 plus 1/3 of 360 is 585. Oh, 585. Therefore, before this, but after this, but very near to this one. Okay. This is actually high school mathematics. Okay. Light line without disturbing, bring it here, bring it here, bring it here. 532.273 from total 1140, subtract this number, you will get 607.727. I rounded to highlight it. Okay. Y bar. How much you got Y bar? 475.913. You got 475.913. 180. Furthermore, 180 plus 270. 450. Oh, furthermore, 180 plus 285. 465. Furthermore, 180 plus 285 plus 1/3 of 255. 180 plus 285 plus 1/3 of 255. 550. Oh, yes, before that one. So, before G4, after this junction, yes, correctly mark x bar. x-axis. This is x-axis. See, y bar, I won't write y bar here. Okay, this is your x bar. Okay, everybody. X bar, y bar, 475.9. I once again maintained here that Aterqui removed. Still, I am continuing with Abelco only. Go here, 475. From total 1020, subtract this number, you will get this number. Okay. Now, ready for moment of inertia calculation about x and y. I will see right angle triangle, isosceles triangle, triangle in general. Now, triangle in general will not come because now onwards you will have only either right angle triangle or isosceles triangle. Because if it is a triangle in general, I told we will divide into two right angle triangles. So now onwards, up to end of our course, it will be either right angle triangle or isosceles triangle. Now, before I start, I will tell once again, last time, see, if there is a right angle triangle this way, anyway, see, if this is B, this is H, anything you can take B and H, centroid is here. See, this is centroidal axis. This is the base. The base is at the edge. If the base is at the edge, then 1/3, 2/3 is known for you. Moment of inertia, you see, remember, whenever the base is at the edge, then this I about this axis is parallel. See, for this axis, parallel is B. B into H cube by 36. And this is another centroidal axis. Now see, again, look from this side. This is the base. If you look from this side, base, this becomes height if you stand from here. So again, the base is again at the edge. So for this axis, parallel side is H into B cube by 36. Therefore, I will not explain once again. See, 240 into 300 cube by 36. 300 into 240 cube by 36. 360 into 300 cube by 36. 300 into 360 cube by 36. I will not explain once again. This triangle. See, for this triangle, see, base is here. 315 into 255 cube by 36. 255 into 315 cube by 36. 315 into 285 cube by 36. 285 parallel side into 315 cube by 36. 600 into 180 cube by 36. 180 into 600 cube by 36. This triangle, be careful. No, but remember, but if it is an isosceles triangle, see, suppose isosceles triangle is this way. For example, if this is the base, if this is the height, centroid is here. See, for this axis, this is the base. Base is at the extreme edge. So, correct. Parallel B into H cube by 36 only. But other centroidal axis, see, this is not the base. It is the common height, or it is the common side for these two. It comes in between. When that parallel side comes in between, it is not 36, it is 48, 48, 48, 48, 48. Okay, then which one first? For the axis which is parallel first, H into, see, for this axis, the parallel is H into B cube by, that is 48. So, H into b cube by 48. 48. Okay. This all I told already hundreds of times. Therefore, see, for this axis now, see, now here the triangle is like this. Okay, no problem. This way. So then, see, this is how much? This is 225. This full is how much? Full 540. See, centroid is here. About this axis, see, this is the base. Yes, base is at the edge. Therefore, see, from the base, this is height. Oh, no problem. It is how much? Parallel side. 540 into 225 cube by 36 only. But about this axis, see, that axis I is, see, this is not the base. It is in between. If it is in between, it is common for both. Then that, see, for this axis, this is the parallel. 225 into 540 cube divided by 48, 48, 48. See here. 48. Okay. Now, if you don't understand and if you do not go through each and everything I tell, and if you do not make a note of all those one and struggle later, you have to pay penalty yourself only. This much effort I am putting. If you cannot utilize it, I am helpless. Okay, start. Now, I about XX. Now, very simple. Now, the most important term is H, red color. That is the most important term. Okay, I will take a little break because talking too much. And relax for 10 minutes and start the recording. Start now. Most probably last time, this type of explanation. I about XX. I about any axis equal to Ig plus A square. Lastly, I will tell. Moment of inertia about an axis passing through centroid of that part considered. If you consider part 1, centroid G1. If you consider part 2, passing to G2. If you consider part 3, passing to G3 and parallel to the required axis. Required axis is XX. So if you want I about XX, come to centroid, you imagine axis parallel to that required axis but passing through centroid. Write I about that axis by using standard formula plus area into perpendicular distance from centroid of that part. If you want for G1, part 1, perpendicular distance from G1, or for 2, perpendicular distance from G2 to the required axis, that is XX axis. And again I will tell you, when axis is horizontal, distance is vertical. So vertical distance square. When axis is vertical, horizontal distance square. And if the axis is horizontal, cubing is always vertical. If the when you write Ig, if the axis is vertical and the axis is horizontal, horizontal side will become parallel side. Vertical is perpendicular. So cubing is always the perpendicular side. So for XX axis, all vertical distance to be cubed. Vertical side distance or side to be cubed. For YY axis, axis vertical, so parallel side is vertical, perpendicular is horizontal. So moment of inertia about horizontal axis means cubing is for vertical side. Second one, distance also is vertical distance. I will not tell again. And I about vertical axis means cubing is for vertical side. Sorry, horizontal side. Already nearing 1:30 or 2 o'clock now. When you want I about YY axis, parallel is vertical. So horizontally parallel into perpendicular cube. H also is perpendicular, horizontal. That's all. Enough. After this, you show me one place where this much explanation given. Show me. Let me see. Okay, start now. Figure number 1. Every time green color required now. Start now. A little fast I will do. Come to figure number 1. Passing to centroid parallel to XX its own centroidal axis. 600 into 540 cube by 12. Rectangle is 12. Triangle is 36, except for isosceles triangle where about that axis which is common for both sides, there 48. Okay. Plus area into, see, this distance square. So red color. See, into this distance square is here. 475.913. 475.913 is from XX to extreme fiber. So 475.913 minus 180 and also minus half of 270. Why? This side is 270. See, this is 540. Half of 540. See, this is 540. So this distance, extreme distance, 475.913 minus 180 minus, see, you should see this dimension now, 540 by 2 minus 180 minus 540 by 2, that is to be squared. Okay, start. Figure number 2. I about its own centroidal axis parallel to XX. 1000 times told, 240 into 300 cube by 36 plus area into from centroid to XX this distance square. Perpendicular distance square is 544.087. 087. See, from this distance subtract this distance, because you want this distance. So this is full distance, subtract this distance, that is 2 by 3 of 300 minus, write horizontally, here space is not there, actually you should write horizontally, minus 2 by 3 of 300, that is to be squared. Okay, over. Come here. I about its own centroidal axis. Its own centroidal axis means parallel to the required axis. See, for this triangle, 360 into 300 cube by 36 plus area into from centroid to here, this distance square, oh, that distance is same as this distance, not required, 544.087. Why? Because both has got same height, minus 2 by 3 of 300 whole square over. Fourth one, I about its own centroidal axis. See, for this triangle, parallel side is 315. 315 into 255 cube by 36 plus area I want to explain, into this distance, see, this distance square. That distance square is from here to extreme top is 544.087. 544.087. From 544.087 subtract 300. Subtract 300. Also subtract this distance, that is 2 by 3 of 255 minus 2 by 3 of 255, that is to be squared. Fifth one, I about its own centroidal axis. 315 into 285 cube divided by 36 plus area into from G5 to this XX, this distance square is this full distance, how much it is? 475.913. See, we want this distance square. this full distance minus 180 and also subtract this distance 2/3 of 285. So minus 180 minus 2/3 of how much it is? 285 whole square. Okay. Sixth one, I about its own centroidal axis. See? Parallel side is 600. 600 into 180 cubed by 36 plus area into from centroid to here, see, from here to here, this distance square. That distance square is 475.913. See, that distance subtract, see, from here to here is this full distance up to here, subtract this distance. That distance is 2/3 of 180 minus 2/3 of 180 whole square. Lastly, this triangle. It is an isosceles triangle. I about its own axis. Oh, it is not the base. It is a common side. Oh, when it is a common side, it is not the base. It is that parallel side. How much it is? 225 into perpendicular is full is what? Full perpendicular. 540 cube by 48 plus area into this distance square is 475.913. We want this distance square. 475.913 minus 180. Also subtract from here to here. That is exactly 270. Either write 270 or write half of 540. Whole square over. Everything is over. Now, class. This is warning only, not advice. Find each, actually what you do is, don't waste time calculating. I told you, if you want to calculate for a fair copy, but what to do is, you should not see my expression. You should take a paper, use this sketch in a drawing sheet, write it. Without seeing my expression, you independently calculate. Slowly, mistake will happen. I know, so many will do mistakes. Then calculate the answer. Find this answer. See, add 1, 2, 3, 4, 5, 6, 7. See, class. Now, Ixx for entire given area is Ixx power 1 plus Ixx power 2 plus etc. up to Ixx power 7. If you cannot do it right now, leave the class. Once again, never attend my class. If you are subscribed already, unsubscribe, no problem. People who will ask, he wrote everything, but finally what to do, he has not told me what. There is a limit. I told how many times? Find all the values, add it, you get the answer. Already told so many times. See, there is some requirement from your sometimes I am little harsh only. I behave more harshly in the offline classes. You don't know. In colleges or you don't know how harshly I behave. But the people I am not offending them. I am not insulting them. I will never tell you are useless. Because if they are useless, then why should I take the class? I will tell, if you do not know, I am there to teach. But what I tell, follow. Okay, over. Now, that way practice. Now, I about YY, I will change it now. Now, I about YY. One last time I will tell. Moment of inertia about vertical axis. Now, everywhere, parallel side is vertical. So, cubing is for horizontal. Distance also horizontal. Sufficient. Okay, start. Now, remember, now about, I not written YY here. I forgot how many, people will comment. He wrote YY, not written. People are there, you don't know. There are people. Okay, start. Come to centroid. Green color. I first see. I about its own centroidal axis parallel to YY. See, this axis. See, correct. What you have to do is, You go through, if you have difficulty of understanding, repeatedly use a laptop or TV, and what I tell, listen again and again. Okay, start. For this axis, parallel side, 540 into 600 cube by 12 plus area into, see, now this distance square. See, now it is from G1 to here, this distance square. That distance square is 532.2. So this I have to remove. I forgot to remove this one. Okay. Forgot to remove everything. Okay. I'll remove it. This is the previous one. I forgot to change it. Okay. And how much it is? 532.273. See, I am writing in front of you. 532.273. See, I want this distance square. This distance minus 225 minus this distance is half of 600. 600 by 2 whole square. Okay, one thing I tell in the last actually. Okay, start. 2. It's here. I about its own centroidal axis parallel to YY. Parallel side 300 into 240 cube by 36 plus area into, see, from G2 to YY, this distance square is 532.273 minus 225, still not over, 225 minus, see, this distance minus this distance is 2 by 3 of 240. You should know correctly 1 by 3, 2 by 3 minus 2 by 3 of 240 whole square. But write horizontally. Here space problem. Okay, start. Figure number 3. First, I about its own centroidal axis parallel to YY. Parallel side is 300. 300 into 360 cube by 36 plus area into, see, this distance square. That distance is 607.727. 607.727. This full from here, see, from here, this, where is it? Here, see, from this XYY, from here to full distance, subtract 315, also subtract this distance is 2 by 3 of 360. So, subtract 315, subtract 2 by 3 of 315. Why 315 2 times? 2 by 3 of 360. Okay. See, sometime I told that's what I want to tell. I will explain correctly here. While writing, in case some number got here and there, what I explained, listen and change it. Don't make an issue of it. See, there is a limit. I am also a human being. And it's actually more than 2 o'clock now. 2:30 now. 2:30 not daytime, night time. So, 607.727 minus 315 minus 2 by 3 of 315. Okay, then this one, fifth one. First, I about, see, which one? This one, now here. Fourth one, I about, which one I told? Third one over. Okay, now here. I about its own centroidal axis. See, parallel side, 255. 255 into 315 cube by 36 plus area into from G4, centroid G4 to YY, see, this distance square. That is 607.727. 727. See, 607.727 minus from here up to G4 is 2/3 of 315 minus 2/3 of 315. Now 1 minute. For fifth one also same thing. See, I about its own axis is 285 into 315 cube by 12 plus area into, once again, same distance. Why? Because these two are horizontally same distance. So how much it is? 607.727 minus 2/3 of 315, 2/3 of 315 whole square. Whole square, don't forget. Now, Sixth one, I about its own centroidal axis. Parallel side is 180. 180 into 600 cube by 36 plus area into from G6 to YY, this distance square is 532.273. 532.273. See, we want this distance square. This distance minus 225 minus from here to centroid is 1 by 3 of 600 minus 1 by 3 of 600. If it is not clearly visible, I am using words. Listen to what I tell and correct it. Okay. Next, lastly here, I about its own centroidal axis. See here. Now, be careful. Now, this is the base. Yes, the base is correctly defined. So, therefore, parallel base is how much? 540 into 225 cube by not 48. I left it deliberately. Once again, 36. Back to 36. Why? Because when you want I about YY, this base is extreme edge. See, this is the height. This is the base. This I told it 100 times already. Plus area into from centroid to YY. See, this distance from here to YY is 532.273 minus from here to here is 2/3 of how much? 225 whole square. Calculate each and every one. Finally add all and get I about YY. But better correctly get the answer. Note the answer. Take your own paper. Don't see my writing. You write independently. Practice to scale your writing. Check the answer. When you get the same answer, see, or at least do one thing. You write the expression. Check whether your expression matches with expression given by me or not. And last I will tell, suppose see, this is 315. I told 315. When I came here, when I write by chance, I look there. If I wrote 360 means you change it. See, I will tell you here. See, I will tell 255 into 315 cube by 36 I will tell. But when I write here, by chance if some other number is written there, it is oversight and human beings. See, that's okay. But actually, no, everything is correct, I think. So, but what important is what I explain. By chance, if I wrote some other number, you cut it and write what I told. See, what I told here counts, not what I write. But you 99.99%, there will be no problem. But sometimes it happens. See, it just now happened once. I put a wrong number there. Okay. That's all. Very thoroughly work out. See, title also you see. I give a special title today. Ultimate master question, for where all type of triangles are considered special. So therefore, till I make a thumbnail, I wrote in a paper. Why? To highlight it. Little later, for the special question, I'll prepare separate thumbnails highlighting something. See, people nowadays, it is that way only. Something highlighted, they want to see it. What is there? Okay. But whatever is there, now onwards, for a triangle, of course, rectangle and triangle, I will not waste this much time. Not waste actually, I will not put this much effort. I will tell next time also, see. But see, my teaching tendency, I am telling, not telling. Still what happens is, I will tell, see this axis parallel into perpendicular. That my students know it. Sir will tell, he will not tell something. But he is again and again he will tell. Again and again he will tell. See, like in structural analysis, there is a method called, what is called Kani's method, where first question, I explain each and every concept very, very slowly. To do one problem, which will take for a student 10 minutes, I take 3 hours. Then I will tell, next time will not tell. But next time also I will tell, be careful, see this value plus that far end rotation contribution, plus far end rotation contribution, far end contribution, plus displacement contribution of the column connected to the joint multiplied by respective rotation factor. I'll keep on telling every class. Why? Because my teaching is that way. I always feel students will have difficulty if I explain, okay, I will spend more time, no doubt, more effort, but it should be useful. Don't worry about this rotation contribution. It is Kani's method. Okay, lot of time is there to come there. Okay, now next class will continue. Next class I will see that semicircle and quadrants are coming. Okay, thank you.